alaikum wa rahmatullahi wa barakatuh. Welcome again to the third video on gas turbine control and control system. As a reminder, in the second video we went through or we gave an overview of gas turbines. In this video I'm going to give you some hints on how to get to know the gas turbine instrumentation. Remember that we said that the goal or the aim behind these videos is to draw the big picture about gas turbine and gas turbine control systems. This is why in the coming videos we'll deal with gas turbine control and gas turbine control system, and at the latest one, the sixth one, we will deal with troubleshooting scenarios, wrapping up all, let's say, the mindset of the troubleshooter when he's faced with problems, whether it is an instrumentation problem, a control-related problem, or problems related to the use of control system. Okay. Gas turbine auxiliaries are there to ensure a good run, a healthy run for your gas turbines. Okay. Once you get to a work site, you will encounter auxiliaries compartment and turbine compartment. From auxiliaries compartment, you will have, as shown here with the green color, you will have in this direction lube oil, hydraulic oil, and control oil. Okay, lube oil to cool the turbine components, the shaft mainly, hydraulic oil to actuate the gas control valve, the stop speed ratio valve, and the IGVs, and the second stage variable nozzles, for the double shaft gas turbines. The control oil is there to hold into a position, and we will see that in the coming slides. It is, let's say, the guarantee that everything is going well, so that the hydraulic oil can perform the task of moving the different actuators. The fuel is driven to the combustion chambers to produce if you want, the energy, the power necessary to rotate the two shafts. Okay. As you can see, first of all, when the oil reaches the turbine compartment, okay, it is being heated. This is why we have a cooling system, a lube oil cooling system. Okay, and to that system, a hot oil goes through if you want, air cooling system. Okay, in general, motor fans, and gets back with a much lower temperature. Okay, we do have what we call an oil mist eliminator, which liquefies somehow the oil vapors coming from the tank, and the oil goes back to the tank again with gases continuing their path to the atmosphere. Okay, the fuel auxiliary system, if you want, is there to guarantee fuel gas with the right pressure and temperature for combustion inside the combustion chamber. Okay, one other more important auxiliary system is the inlet air filter system, which is used to filter the incoming air from the atmosphere. Okay, so that the combustion takes place, and to protect the axial compressor from, let's say, any solid components. Okay, because remember, this is going to rotate at very high speeds, and with solid let's say I don't know, solid components, this can damage the compressor blades, compressor vanes, or turbine blades. Okay, this is so the sixth system, and one might also get to know and give some focus to this system, the CO2, if you want, system, which is used to extinguish fires in both compartments, in the auxiliaries compartment and also in the turbine compartment. Okay, this is the big picture about auxiliaries coming with the gas turbine package. Okay, but let's focus on one of the most, if it's not the most important auxiliary system, and that's the lube oil system. Okay, and by that I'm referring to a complete system starting from the lube oil, as I said, used to let me bring a green color, used to cool the shafts, if you want, mainly. And from that lube oil, okay, we go through a hydraulic oil system, which is used to actuate the GCV, gas control valve, and the stop speed ratio valve, the SRV, okay, in the fuel gas system, okay, prior to going to combustors. And hydraulic oil also is used to actuate the IGVs at the entry of axial compressors. These IGVs are used to protect the axial compressor. Okay, this is the turbine wheel. They are used to protect the axial compressor against what we call compressor stall. Okay, you can YouTube that and or Google it and find more about that. But mainly this happens by closing the IGVs at low speeds of the shaft and opening it at higher speeds. And at higher speeds, remember, we'll be having more fuel, which means we'll be having also more heat. So for both, if you want, objectives, we already protected the axial compressor against stall. It's okay. And now, because we are having more heat, we need to cool down. The gas turbine needs more air to be cooled. So the IGVs are open in advantage to allow the cooling of the gas turbine components. Okay, this is about IGVs. And the fourth actuator is what we call second stage variable nozzles. And remember that the second stage variable nozzles comes between the HP, if you want, between the GG, okay, and the power turbine. Remember that? Okay. The second stage variable nozzles are being actuated by hydraulic oil, okay, and they go from, in general, with the GE gas turbines, from plus 15 degrees to minus 5 degrees, and with that the speed of power turbine is going from a speed that if you want, guarantees a minimal load, okay, to a speed where a maximum load demand is being satisfied. Okay, and another very important system with the Lube oil system also is the control oil, which has as a source the lube oil also. This comes at a pressure around 5 bars, and the hydraulic oil around the 80 bars. Okay, so the control oil is used, as I said earlier, to maintain or to allow the hydraulic oil to get to the actuators. Okay, somehow let me drive it in draw it, sorry, in a better manner. Let's say it comes here to actuate a valve to open the path for the hydraulic oil to get to the second stage variable nozzles, and also to okay, yes, one of the paths, the path of the hydraulic oil getting to the SRV is being controlled also let it be this way, with what we call a dump valve. Okay. Let's take it from this way. This dump valve, or these two dump valves, should be activated hydraulically by the control oil. If not actuated, the path of the hydraulic oil to the SRV and to the second stage variable nozzles is being closed by these hydraulic servo valves, if you want, dump valves. This is what we call a dump valve. Okay. Now, let's zoom in somehow the Lube Oil System. Okay. What we can see, we have first of all the Lube Oil tank. Okay, which comes with some capacity and operating pressure and temperature. You should notice that. Okay, and we can locally check for the level through what we call level gauge. Okay, and yeah, we can locally also check the differential pressure, okay, between the atmosphere and the internal, if you want, of the tank. Okay, and why is that? We'll check it later. This is a sign of the buildup of vapors inside your lube oil tank. And if vapors are being produced, remember that from the tank, the lube oil goes to the bearings mainly, bearing 1, bearing 2, bearing 3, and bearing 4, okay, to different bearings. And from those bearings, the lube oil is being drained, okay? They are being drained to inside the lube oil tank. We do have different conduits bringing the lube oil back through what we call drains. Okay. And this takes place by gravitation. Okay, there is no mean to pump, if you want, that lube oil back to the tank. It comes only by gravitation. So if vapors build up inside the tank, there will be high pressure which resists the flow of that lube oil back to the tank, and with that, the heat which is being absorbed from the shaft, there is less efficiency, if you want. Okay, so the shaft will not lose heat, okay, and it starts overheating, if you want. Okay, and this is very dangerous to the gas turbine. Let me take this off. Okay, so that this has been explained. Let's understand the flow of the lube oil. We do have what we call the main pump, the auxiliary pump. Okay, the main pump is driven mechanically by the AGB, auxiliary gearbox, which is being rotated by what? By gas turbine shaft. Okay, at what we call minimum operative speed. Okay, but at first, remember that the gas turbine shaft is being turned by what? By what we called starting mean. Okay, so at low speeds, the main pump cannot deliver the right pressure, the right discharge pressure. This is why we have the auxiliary pump over here, the P2. And look over here, they discharge at the same line. And from that point, the lube oil goes through what we call the cooling system. Okay, I'm representing one only fan over here, whereas in real cases, one might find, let's say, three cooling systems, three motor fans. Okay, with the help of the temperature control valve, which comes in general as a self-regulating valve set at a particular temperature, in general around the 50s, okay, 50 degrees Celsius. And this TCV, temperature control valve, is what we call a three-way valve, okay, three-way control valve. As you can see, it either allows the oil to flow through the cooling system, okay, or through the bypass line, okay, and that cooled or bypassed oil comes through this output and then through filters, okay, and then it passes through what we call pressure control valve or relief valve, pressure relief valve, VPR, okay, and this VPR is in general set at around 1.7 bars, okay, that's the pressure of the oil reaching all the bearings, okay, and you can see over here another destination of the lube oil, and that's, if you want, the source of your hydraulic oil in general, okay. uh, yeah, let me duplicate it, okay, and I will take off some comments to focus on another, if you want, equipment, and that is the emergency pump. Okay, let me take off some colors. Yeah, the emergency pump is used, as its name suggests, in emergency cases, and it takes another path for the oil. If the oil goes from the emergency pump over here, it bypasses the cooling system. It goes directly through filters, then to the VPR, to the bearings, okay, and in general its pressure is much lower. If you want, P1 is superior than P2 is superior than P3. P3 in general is around 2 bars, P1 is around 8 bars, let's say, P2, sorry, and P1 comes around 10 bars in general with heavy duty GE heavy duty gas turbines. Okay, this is it. It is this emergency pump is driven in general with a DC pump, a DC motor, sorry, and the auxiliary pump is driven by an AC pump, AC motor, sorry, again. AC motor for the auxiliary pump and DC motor, this is AC, and DC motor for the emergency pump, okay. Now let's move forward with the hydraulic oil system. I already mentioned that it has as a source the lube oil system. It goes through what we call a hydraulic pump, okay, which has again a discharge pressure of around 80 bars, okay. It goes through some relief valves set at 80 bars. Again, we find filters, And from there, as I mentioned in an earlier slide, it either goes to IGVs or second stage variable nozzles or SRV, which is top speed ratio valve or gas control valves. Okay, so wherever you have an actuator, you need what we call hydraulic bars. Okay, there are some details. I'm not going to go through that. When it comes to, for example, nozzles, the hydraulic oil goes through some accumulators which serve as a filter in an electric circuit, okay, to absorb any ripples in the hydraulic oil collector, if you want. Okay, so to allow smooth and precise control of your actuators. Okay, so as I said, we do have different actuators, okay, for the second stage variable nozzles and for the IGVs. Okay, yeah, I'm going later to recommend some videos to watch on YouTube. Okay, I'm not going to spend more time on the details, because all I need you to understand for now is the big picture. Okay, look over here for the GCV and SRV. There is a one complete, if you want, a block of GCV and SRV, in which inside we will have a particular filter, and from there it goes through what we call servo valves, and those servo valves in general you will find the Moog models, okay, or let's say the ABEX models, okay. And as I said, I will recommend some videos later for you to watch. But remember, when I said SRV, I said there is what we call a dump valve, okay. In this case, it is a solenoid valve. But in general, with heavy-duty gas turbines, double shaft, one might find a hydraulically actuated dump valve, which is not a solenoid like this one. You will find, okay, hydraulically actuated, if you want, a dump valve, which is kept open by the control oil, which has as a source, as I said, the Lube Oil System. Okay, this is it when it comes to if you want lube oil, hydraulic oil, and control oil systems. I recommend for all those, if you want, systems, I recommend you go through their P and IDs. Okay, you should check the P and ID for each individual auxiliary system. There is one very important PNID in general, which is the gas turbine control and protection. Okay, all the others cover the auxiliaries, but there is one which covers the instrumentation which comes with the gas turbine, related to your gas turbine. Okay, as you can see over here, because this is a rotating machine. Sorry, my pen ran over. It's over. Yeah, as you can see over here, we have speed pickups, vibration pickups, and temperature, if you want, elements, either RTDs or thermocouples, used to measure the speed, vibration, and temperature of your shaft. Okay, we have LVDTs and servo valves next to the IGVs. Okay, LVDTs and servo valves for the second stage variable nozzles. We have uh, thermocouples for different bearings, and thermocouples for what we call wheel space. For each shaft, we might have thermocouples over here. Okay, thermocouples for the after and the, if you want, the forward and the afterward for each wheel. This is what we call wheel space temperature. And we do have again speed pickups for the power turbine. Okay, speed pickups also for the load if you want in the case of the compressor, LVDTs and servo valves for SRV and GCV, and mainly the flame detectors inside your combustion chambers next to what we call spark plugs. Okay, spark plugs over here. This is it. So one should ask a very big question, which is, okay, how is it being used? How is each individual instrument, how is it being used to control or to protect your gas turbine? And for that, I have drawn this, if you want, slide. You can recognize different philosophies. I urge you to notice this one. Look over here. In gas turbines, we use directly thermocouples or RTDs to a particular input module. If it is a Mark 6E, one might encounter what we call PRTDs, or for RTDs, PRTD, sorry, and PTCC for thermocouples. So in general, the treatment is not with transmitters like in DCS applications, okay, but we do have special IU modules, IU packs as we call them, for a particular type of entry, for a particular type of input. Okay. Remember when we said lube oil, for example, we do have what we call electric heaters. Okay, electric heaters, and for that, the control system receives the temperature of the lube oil. If it is low, the system is used to turn on or off your electric heater. Okay. For pressures, let's say for the pressure between the SRV and GCV, this is SRV, this is GCV. Between them, we do have this setup with three pressure transmitters, if you want. In general, the medial logic is being used, which means we take the intermediate value. Let's say this value, this pressure transmitter, the first one gives 3 bar, and this gives 4 bar, and this gives 3.5 bars. These in between these values, 3.5 is the median value. So the system uses that for indication inside your HMI and for control purposes. Okay, sorry. Another logic where a single transmitter is being used either for indication and control. Okay. Another logic also is used, the mean of 2 transmitters or multiple transmitters. For example, this the mean of 2 temperature transmitters, temperature thermocouples if you want, is being used for wheel space temperature, wheel space, and the mean of multiple thermocouples is being used for exhaust temperature. Okay. Yes. One final, if you want, reminder is the following. Some speed pickups are being connected to what we call the safety instrumented system. Okay. And other speed pickups are being connected to the Mark 5, Mark 6, or Mark 6E control system. And for control purposes, we use the medial logic, okay? And for protection purposes with the SAS system, either the protection module or the protection, if you want, safety instrumented system, the volatile logic is being used. So if 2 out of 3 speed pickups indicate a very high speed, an alarm is being generated and a trip, which is an emergency shutdown, takes place. Whereas the 3 other speed pickups are being used for gas turbine control, okay? And if a speed reaches, the median speed reaches a very high speed, an alarm is generated, and again, a trip, sorry. Excuse my very bad quality of drawing. Okay, an interlock over here, which is to trip your gas turbine. And if you are new to this field, okay, a fresh graduate or new to the instrumentation, I recommend you visit or you read and go through ISA standards, International Society of Automation, Series 5, which means 5.1 for symbols, for different symbols to get to know them, 5.3 for annunciators, etc., 5.20 for sorry, what we call spec forms, okay, etc. I urge you to check that, Google it, and YouTube it, and you will find people introducing those to you. And there is okay, in general the standards are if you want have a cost, okay, and if you want a free tutorial about that, check for a book named okay, you Google this one, you Google Socratic instrumentation, okay, Socratic instrumentation, and inside that book you might find very if you want, self-explanatory chapters about different instruments. Okay, with that we get to the recommendation I promised. You have on YouTube, okay, go and look for frame 5 gas turbine. You will have 2-hour videos with clear animations explaining different instruments and control, if you want, the gas turbine control also, okay. And to further your knowledge about the gas turbine instrumentation, I recommend you go through your own plant PNIDs, okay, field instrument list, PNIDs, to get to know all the auxiliaries and the instrumentation of each auxiliaries and what's being used to control or to protect, okay. And the field instrument list, you can use it to have, if you want, the values for okay, the set for alarms and the trips, okay, so that you get if you want, a good understanding of your physical parameters. The instrument loop diagrams will explain the wiring, okay, through which you will understand the wiring of your transmitters from the field to, as I said, to the technical room, to the control panel, okay, to the turbine control room. The hookup drawing will show you the mounting, okay, what's being used, what are the fittings used to mount individual instruments or sensors, okay, sensor mounting, if you want. Okay, with that I thank you, and as always, excuse my my, if you want, spontaneity in the explanation. I'll be back to you inshallah next time with the 4th video on gas turbine control. I thank you and see you next time. Assalamu alaikum.